Okay. So there are 12 unknowns going in. So next, mass balance. There are a total of 4 species: water, La, PLA, and catalyst. So our mass balance is 4. We're initially given 6 mass fractions. These 1, 2, 3, 4, 5, 6. And we're given one ratio, which you can't see yet. There we go. It's this ratio given here. 1. And we'll go ahead and set a basis, which is M3 is equal to 100 grams per hour. 1, and that gives us a degree of freedom of 0. So now Brittany is going to go ahead and show you how to do mass balance equations.
So we're going to go ahead and start with our general accounting equation, which is up here. And that is accumulation is equal to in minus out plus generation minus consumption. But as we stated earlier, it's a steady state system, so accumulation is equal to 0. We also stated that there are no reactions, so generation and consumption are also equal to 0. And from this, we have a revised accounting equation of in is equal to out. So now we can go ahead and do our mass balances. Starting with water, you can take the mass fraction of water in stream 1 times the flow rate of water in stream 1, and add that to the mass fraction of water in stream 2 times the flow rate in stream 2, plus the mass fraction of water times the flow rate in stream 3, and that's going to equal the mass fraction of water in stream 4 times the flow rate in stream 4. For the catalyst, we're going to do the same thing, taking the mass fraction of the catalyst in stream 1 times the flow rate in stream 1, plus mass fraction of the catalyst in stream 3 times the flow rate in stream 3. And that is going to give us mass fraction of the catalyst in stream 4 times the flow rate in stream 4. And now we're going to do LA. Same thing. Mass fraction of LA in stream 2 times the flow rate in stream 2. Plus that of stream 3. That is going to give us the max fraction of LA in stream 4 times the flow rate in stream 4. And last, we're going to do PLA. And that is going to equal the mass fraction of PLA in stream 3 times the flow rate in stream 3, giving us the mass fraction of PLA in stream 4 times the flow rate in stream 4. And then from this, we can go ahead and do a total mass balance, and that is just going to be that the flow rates of stream 1, 2, and 3 are equal to the flow rate in stream 4. So now we're going to go ahead and start solving some of these for the flow rates, and Manon's going to show us how to do that.
Okay, so first we're going to solve for PLA. So here's the equation that Brittany just wrote on the previous slide. So we're going to go ahead and move things around so that we can solve for M4. So we have M4 is equal to 0.03 times M3, which we stated in the basis is equal to 100 grams per hour, divided by 0.01. So M4 is equal to 300 grams per hour. All right, so then we're going to go ahead and solve for M1 in this equation using the catalyst. So after moving things around, we should get M1 is equal to 0.15 times M4 we just solved for, which is 300 grams per hour, minus 0.02 times M3, which is 100 because of our basis, divided by 0.45. And this will give us M1 is equal to 95.56 grams per hour. And because of sig figs, we're going to say that that is 100 grams per hour. And finally, we'll solve for M4 using the total mass balance. We're solving for M2. We already have M4. So M2 is equal to M4 minus M3 minus M1, which is 300 minus 100 minus 95.56. And that'll give us 104.44. And again, sig figs will be 100 grams per hour. And so now Brittany is going to go ahead and show us how to do mass fractions.
Okay, so we're going to start with our ratio that we described earlier. And since we have now solved for the flow rates of M2, and we already know the mass fraction of LA in stream 3, we can go ahead and solve for the mass fraction of LA in stream 2. So that's just going to be 2 times 0.2 times the flow rate of stream 3, which is 100 grams per hour. This is going to be divided by flow rate in stream 2, which is 104.44. This is going to give us a mass fraction of LA in stream 2 of 0.383. Now we can go ahead and use that plugged into the mass balance equation for LA to solve for the mass fraction of LA in stream 4. So we're just going to do the same thing. We're going to plug in what we just solved for. Multiply that by the flow rate in stream 2. 0.2 times flow rate of stream 3. That is going to give us flow rate of LA. Sorry, the mass fraction of LA in stream 4. We can go ahead and divide that by the flow rate in stream 4, which is 300 grams per hour. And this is going to give us a mass fraction of LA in stream 4 equal to 0.2. So now that we have both of these numbers, we can go back up to our diagram. We can plug in these numbers for LA in stream 4 and stream 2. And then from that, we can find that the mass fraction of water in stream 4 is 0.64, and the mass fraction of water in stream 2 is 0.617. Okay, we can say that using the general accounting equation, degree of freedom, and mass balance equations, we were able to solve all the mass flow rates and mass fractions into and out of this system.
We hope this video was helpful for you. Thank you for watching.